Hey everyone, welcome back to Bon Science. Today we are going to be going over Unit 2, Topic 4 in AP Chemistry, which is called Structure of Metals and Alloys. This one builds off of some stuff we did earlier on, and it's pretty simple, so let's get straight into it. So if you remember back to the episode on bonding, which I believe was Topic 2.1, we discussed metallic bonding there, and I talked about how metallic bonding has this thing called the sea of electrons. I'm not going to review that in this episode. Go check out 2.1 if you would like to see that. However, we are going to talk about how the AP will give you diagrams of metallic bonding. And the way they do this is they show you a bunch of positive ions. So you'll see like a bunch of these positive ions next to each other. It'll be bigger than this. You'll see a ton of them. But then you'll see these electrons, and I'll make the marker thick to make it really pop out, but you'll see kind of like electrons completely scattered just randomly, right? Like wherever. There's no like set pattern, and that's because of the sea of electrons, right? So you've got the positive ions because the electrons are delocalized, so it's kind of really just like the nuclei, and then the electrons just kind of floating around freely, flying around, and so that's typically how you will see a metallic bond represented. Now the bigger thing in this unit is an alloy, right? Is what alloys are and the types of alloys. So alloys are mixtures of different metals. So I'll say alloy is a mixture of metals. And that's really as much as you need to know as far as for what an alloy is. And a really good example of this is brass. So brass is a combination of copper, which is Cu, and zinc, Zn. And brass is a really great example because it's probably one of the most famous examples. Because if you are a musician, brass is what's used to create the brass instruments, right? It's in the name. Things like your trombones, your tubas, your trumpets, all of that is made of brass, which is just to say it's made of this mixture of copper and zinc. Another very great example of this is copper and tin is Sn, element number 50. That alloy is known as bronze, which is obviously a very famous one. If you've ever taken a history class, which I hope you have, then you should know that the Bronze Age is a thing, and that's what it is. It's a mixture of copper and tin. So as far as alloys go, you also need to know the two different types. And the two different types are interstitial alloys, which is spelled like this, interstitial. And then the other type you need to know is substitutional, which that one's probably a little easier to spell, but substitutional. And the main difference between the two types of alloys is it's really just the size of the component atoms. So in an interstitial alloy, the atoms are very different sizes. So I'll just say interstitial is different sizes. Substitutional is when you've got the same or the similar size. So I'll say same / similar. And so you might be wondering, okay, well, how do we determine whether it's like if they're different enough to be interstitial or substitutional? And thankfully that's really easy. You just reference your periodic table. The general rule of thumb for determining whether you are dealing with an interstitial alloy or a substitutional alloy is literally just look at the periods that the elements are in. If they are on the same period, same energy level, or they are within one energy level of each other, then you will see a substitutional alloy because their size isn't that different. So for example, if you have a metal in period 4 and period 5, that'll form a substitutional alloy. If you have a metal, period 4 and period 5. If you have two metals in period 4, then you will get a substitutional alloy because they're like the same size, right? So for example, brass, copper, and zinc, those are on the exact same period. So you would probably on the AP say that brass is a substitutional alloy, and in fact, it is a substitutional alloy. Okay, so that's substitutional. The other type of alloy is called interstitial. And an interstitial alloy is just going to be when the two constituent elements are more than one energy level apart. The best example of this is steel. Now, steel's a little weird because I know I just told you guys that an alloy consists of two or more metals mixed together. Steel is iron plus carbon, and carbon is a non-metal, but we consider steel an alloy. So it's the best example, so that's why I'm giving it to you. But an alloy is still going to be two or more metals combined, so don't get that confused. But this is interstitial because if you look at the periodic table, you see iron is on our period level 4, but carbon is on period level 2. So they're more than one, not period level, energy level, sorry. They're more than one energy level apart, which means you have an interstitial alloy. And the reason they're called interstitial alloys is because you have the bigger atoms like this, right? So you'll have like the bigger atoms here. And then you'll see that the smaller carbon atoms fit in the middle, in between the bigger atoms, right? And that's why I say interstitial, because it's the Latin word for between, and so it's like between the bigger atoms. And so this is actually, sometimes people do this, they'll give you a diagram of an alloy, and they'll be like, is it interstitial, is it substitutional? The way you tell that is if you see a bunch of big atoms and then just some smaller atoms in between, you have an interstitial atom. So this is an interstitial, or I. Substitutional, they'll all borderline be the same size. Like you can see here, I'm trying to draw these of the same size. Maybe they don't look like they're the same size, but pretend they were. Then yes, we would consider this substitutional on the AP. And so know those diagram differences, know the actual differences. Interstitial is more than one energy level apart, substitutional is one energy level apart or on the same energy level, and then just know what an alloy is. But that's all you need to know for this lesson. I hope it all made sense. I hope you enjoyed it. Please like and subscribe, and thank you. I'll see you in the next one.